Only 20 are there. Why late? Earlier lecture was going on. Hello. Okay.
No, ma'am, there was no lecture.
No lecture. Okay, fine. Why late? Only 22 are there. Okay, I'll start. So see, first step, all of you please observe circuit. Hope everyone solved it at home because it was homework. Okay. So just a minute, let me adjust this bar somewhere. Okay. What you have been asked in given circuit, you have to find out the current flowing through 4 ohm resistance. Okay, for it's a 2 ohm, 3 ohm. This one is 4 ohm, another one 2 ohm is there, 3 ohm and 20 volt. Okay, like this is the circuit given. So you have been asked to simplify it using Kirchoffs law. Using Kirchoffs law, you have to find out the current flowing through 4 ohm resistance. Okay, so this one here, 4 ohm resistance. So what is the first step? Whenever you have been asked to simplify the sum using Kirchoffs law, what is the first step? Yes, who can tell? Hello?
Current direction.
Correct. Very good. First of all, you have to represent branch current direction. Okay. So current direction, while apply Kirchoff's current law. Any current direction you can select. Only the thing is apply KCL, Kirchoff's current law. So see, from positive terminal of battery, current I is shown. Then once it reach to node A, it has two paths. Some current will flow through 3 ohm, that is I1 mark over here, and the rest current, that is I2, will flow through 2 ohm. Okay, so I2 is what? I minus I1. Got it? So you can write rather than I2, I minus I1 also you can write. Doesn't matter. Here they have used I2 variable. Okay, once this I1 reaches to node B, again two paths it has. Some current I3 they have represented flowing through 4 ohm, and how much current will flow then through 2 ohm? I1 minus I2. Okay, once I2 and I3 reaches at node C, I2 plus I3 will flow through 3 ohm, and once this is I1 minus I3 coming toward node D, and I2 plus I3 coming toward node D, then their resultant will be I3 will cancel, I1 plus I2. That is total current I will move back to battery 20 volt. Is this clear to everyone? Branch current direction? Hello?
Yes.
Please mute yourself. Mute yourself, others. Okay, background sound, please. First step is to represent branch current direction using KCL. Okay, what is the second step? Yes, who can tell second step?
Apply KVL by using loops.
Correct. Apply KVL. But before it, first of all, you find out the number of unknowns. How many number of unknown parameters are here?
3.
3 unknown parameters, right? I1, I2 and I3. Once you know the value of I1 and I2 and I3, I1 and I2, you can easily find out I. So we'll consider only 3 unknown parameters, that is I1, I2 and I3. Okay, if 3 unknown parameters means how many equations will be required? KVL equations. 3 KVL equations will be required, right? Okay, so for 3 KVL equations, you have to select the 3 loops. Okay, 3 closed loop. So for that, this is the first loop we are going to select. Okay, second loop, all of you can see here, both are clockwise, and third loop is this one, that is also clockwise. Clear? Okay, so 3 unknown parameters. 3 KVL equations will be required. So for that 3 KVL you have to select 3 loops. Okay, so first one, second one, and third one. Loop direction you have to select. You can select any loop direction, clockwise or anti-clockwise. Okay, so we have selected clockwise here. So clockwise loop direction. So apply KVL to all 3 loops. Now while applying KVL, what you have to do? Whenever you are moving from higher to lower, mark it as negative, and lower to higher, that one you have to mark as positive, whatever it is, voltage drop or voltage source. Before it, one step left. Once you mark branch current direction, with reference to that you have to mark the polarity. Okay, so this terminal will be positive and this will be negative for 3 ohm. For 2 ohm, as current is entering over here, this terminal is positive and this one is negative. For I2, for 3 ohm, this one will be positive and this terminal will be negative, and here also this one is positive and this one is negative. For 4 ohm, this side is positive, another one is negative. Is this clear to all of you? Yes, polarity of voltage drop.
Yes, sir.
Yes, ma'am.
Okay, got it. Now go for loop 1. Now in loop 1, is there any voltage source?
No, ma'am.
No voltage source is there, only voltage drop. Means
No, ma'am.
on left hand side you will get 0, right? Only right hand side I1, I2, only I1 and I3 will be there, because I2 not there in this loop. No, I2 is also there, sorry. So I1, I2 and I3, these terms will be there. Okay, so what's about move clockwise? While moving clockwise, what's about 2 ohm resistance? Positive or negative? Hello?
Negative.
Negative.
Negative, right? And 4 ohm?
Positive.
Positive, correct. And what's about for 3 ohm?
Positive.
Correct.
Positive.
Okay. So write the
Positive.
equation. Correct. Positive. So you will get this equation for the first loop. Similarly, go for second. Similarly, go for third loop. Now no need to explain in detail. Directly equation can I show, or should I explain? Directly explain. Okay, fine. So first loop equation, everyone, is it clear? First loop equation. All of you got it? First equation. Can we go for
Yes, ma'am.
next? Can we go for second loop? Okay. Now observe the second loop. How we are moving in second loop? In clockwise direction. So while moving clockwise direction, what's about 4 ohm? Current flowing through it, I3. So 4 times I3 will be positive or negative?
Negative.
Negative. Because see, we are moving from higher to lower. So minus 4 times I3. What's about 3 ohm? Negative, correct. Minus 3 times I2 plus I3. And what's about 2 ohm?
Positive.
Plus 2 times I1 minus I3 is equal to 0. Got it? Minus 4 times I3 minus 3 times I2 plus I3 plus 2 times I1 minus I3. So this one equation, got it? Second loop. Same equation, same loop. Okay, so is this, are you getting second equation? Same. Can we go?
Yes, sir.
Okay, can we go for third loop? In second loop also no voltage source is there. So on right hand side you will get here 0. Got it? Here also in first loop no voltage source. So right hand side 0. Got it? Can we go for third loop? Hello? Can we go for third loop equation?
Yes, ma'am.
Okay, so here they have shown the polarity. Okay, So see, for third loop again we are moving clockwise. So what's about just a minute, let me check this. Plus minus, just I'm checking the polarity. Correct. Okay, so now see the third loop. In third loop, move clockwise. So what's about 20 volt, plus or minus? Minus, correct. Minus 20. What's
Minus.
about 3 ohm? Voltage drop across it?
Plus.
Plus, correct. Plus 3 times I2 plus I3. What's about 2 ohm again? Plus 2 times I2 is equal to 0. Minus 20 volt plus 3 times I2 plus I3 plus 2 times I2 is equal to 0. Okay, so after simplifying, you will get the third equation, this one. Clear to all of you?
मैम
Yes.
मैम
Yes.
लूप 3 में कुछ स्पेसिफाइड नहीं है, तो फिर इसके लिए हम दूसरे से भी कर सकते हैं, ए बी डी ए से.
मैंने वैसा ही किया.
Third loop, any third one loop, any you can take. A, B, D, A. That also you can take. Suppose I am going to mark this one as point E. So you can select third loop as A, B, D, E, A. Got it? Clear?
Yes, sir.
Any loop you can select. Okay. Only the thing is, while applying KVL, whatever the loop you have selected, form the equation correctly. Don't do any mistake. Okay. Actually, here how many loops are there? 1, 2, 3, 4. How many loops total? Yes, who can tell?
Hello, miss.
How many total loops are there? Closed loop in this circuit?
5.
5.
Right, 5 loops are there. So out of 5, any 3 you can select. Got it? 6. 3 are there. This one is fourth one. And inner one is only 5 are there. Right? Hello?
Hello, miss.
Only 5 are there. Huh?
Yes, ma'am.
मैम ऐसे और भी हैं, अगर ऐसे करते ए बी सी डी और ए करते वापस, और मतलब ए बी
And we
सी
can go like
डी.
A, C,
right.
then
Right.
A,
No,
B,
no,
C, D.
right.
Then we can do A, B, D.
Correct. More than 5 are there actually. More than 5
Yes,
means that one is 5. This means this one A, B, C, D, E, A. This one also. Similarly, in another fashion, then A, C, D, E, A. No, sorry. A, C, B, D, E, A. So 5, 6, 7. 7 loops are there. Right? Right, na? Okay, so out of 7 loops, any or maybe more than that. So out of this, you can select any 3 loops. Clear, everyone? So apply KVL to 3 closed loop. We have selected these 3 out of 7 loops. Any 3 you select. Once you get these 3 equations, write them in matrix form. Okay. So have you tried anyone how to enter these 3 equations in the matrix form in calculator? Anyone tried?
No, ma'am.
Okay, so in next lecture we'll do it. Okay, if you see, I think all of you can do that because smartphone you are using means that also you can do. It's a user friendly calculator. Only mat function you have to use, mat, M-A-T. Okay, this mat function you have to use, mat for matrix. Then I told you, first of all, you have to select the matrix A and B. Then you have to select the dimensions of both. A is 3 by 3 and B is 3 by 1. And then enter components. For A matrix, you have to enter all 9. Right, like A11, A12, A13, it asks for that. And once you enter matrix A, enter B matrix, it asks for 1, 1, 2, 1, 3, 1, like this. Okay, and then go for A inverse B like this. Okay, you try today. If you can't, I think on YouTube video definitely will be available for that. We'll share link with you, and still if you don't get, then I'll switch on my video and then we'll show you. Okay, you try it, it's very easy. Okay, got it. Try to do the things on your own. Your brain will become more active, more sharp, rather than spoon feeding. Keep habit now onwards to do things on your own. It will be better for you. Okay, so Cramer's rule, you can use del by del 3. So this is the del matrix, that is matrix A, and replace del 3. You have to find out. See, current we have been asked to calculate which one? Current flowing through 4 ohm resistance. Through 4 ohm, which one current is flowing? Yes, which one current is flowing through 4 ohm?
I3.
I3. This third column of del matrix you have to replace. So compare del and del 3, you will find third one is different. First two are same. So del 3 by del is I3. I3 you are getting how much? Minus 0.625 ampere. Minus means what? I3 in which direction
The
we have
direction is
shown?
changed.
Right. Direction we have shown forward. Okay, direction you observe for I3. We have considered or we have assumed it in forward direction. So practically here it will flow in reverse direction. That is its meaning. Whatever the direction you have assumed is wrong. That's why you are getting answer minus. Wrong, or you can say reverse. You have assumed reverse direction. Practically it will flow in reverse direction. Okay, whatever you have assumed. See here it is written negative sign indicates I3 actually flow from C to B. Okay, we have assumed it is flowing from B to C. So whatever you have assumed is wrong. Practically it will flow from C to B. Clear? Is this clear? You will get full marks for this. Even if you write just minus 0.625 ampere, then also you will get full marks. If they specifically ask for current direction, then mention as I am getting a negative answer, as value of I3 is minus or negative, so current will flow from C to B instead of B to C. That's it. Okay, if they don't ask for current direction, no need to mention anything. If you want, still if you want, you can. So got the sum? Everyone?
Yes, ma'am.
You got the
Yes, ma'am.
confidence that you can simplify the sum using
Yes,
Kirchoffs law?
ma'am. Yes, ma'am.
Okay. So what you do now, 2-3 more sums you practice on Kirchoffs law. Okay. Whatever the method I have explained you, not necessarily you should use that method in 12th to form KVL equation. If you have used different method, that also you can use. Okay. Someone use loop analysis, that also you can use here. Okay. Means they don't mark polarity. I use the method to mark the polarity of voltage drop across each resistance. That one they don't use. So you can apply your method. Only the thing is what? Represent branch current direction and form the KVL equation correctly. These two things are important. Okay. Mark correctly branch current direction means KCL you are applying correctly. You apply it. And form the KVL equation means KVL you have applied. So Kirchoff's current law, Kirchoff's voltage law, and then you can use Cramer's rule, or directly calculator you use. Directly you will get the values of I1, I2, I3. So whatever you want, that direct answer you can write. Okay. Now what you do at home, what today's exercise for all of you, you solve 2-3 more numericals on Kirchoff's laws. Okay, got it everyone?
Yes, ma'am.
Okay, fine. Now can we go for superposition theorem now?
Yes, ma'am.
Okay. So now everyone please try to solve 2-3 more numericals on Kirchoff's law. Material I already forwarded to all of you. Okay. So in that enough numericals are there. Difficult circuits you please try to solve. Means you will get the confidence that numerical on Kirchoff's law you can solve. Now next one is superposition.
Hello, ma'am.
हाँ, yes.
हाँ मैम, पहले के क्वेश्चन में मेरे थर्ड लूप जो है ना वो ए बी डी सी ए ये लिया था.
No problem.
तो
No problem.
तो उससे मेरा आंसर 0 एम्पियर आ रहा है.
हाँ, means what you have done, first two equations correct you got?
Yes, yes ma'am.
Okay, so then what you do for the third one equation, you have formed wrong. Okay, correct करो third one equation, फिर से solve करो. Okay,
मैम
correct.
थर्ड वन में क्या जो वोल्टेज ड्रॉप है सिर्फ उसमें वोल्टेज सोर्स है ही नहीं, इसलिए वो जो बी मैट्रिक्स है वो 0 हो रहा है फॉर्म.
Right. What does it mean? So any three you can't select. What is the conclusion? Everyone please listen, very good point. Okay, means any three loop you can't select, at least one loop you have to select with voltage source. Got it everyone? Clear? Yes. Huh?
Yes.
Okay. So third
Yes,
one
ma'am.
loop means out of 7 loops, 2 loops, any 2 loops you can select, but the third one must have, or any one loop must have the 20 volt voltage source in it. Clear?
Yes ma'am.
Okay.
Yes ma'am.
Means whatever the 3 loops we are going to select, out of these 3, at least one loop must contain 20 volt voltage source. Okay. You can't
मैंने दूसरा लूप मतलब ABDA लिया है, तो मेरा आंसर
बराबर आएगा. उसमें 20 वोल्ट है, तो आपका जो B मैट्रिक्स है it will not be 0. What one student asked the query, third one, he has selected A, B, D, C, A. Means in all the 3 equations, 20 volt voltage source is not there. So in all the 3 loops, so B matrix will be 0, 0, 0. Okay. Whatever the B matrix, it's all 3 values in one column. So 0, 0, 0. So what is the conclusion, everyone? Very good point. This one actually I forgot to tell you. So out of these 3 loops, at least one loop you should select so that 20 volt voltage source must be there, or current source. Okay, clear everyone? So whoever asked the query selected loop ABDCA, please select this one loop, third one, with 20 volt. Clear? So
Got it.
okay, very good. So now what you do, everyone?
Ma'am.
Yes.
Ma'am, the book PDF that you have given on linear algebra.
Yes.
Are there some parts in the book that are
not linear algebra? It's a local author. LA stands for local author. Yes.
Okay. Local author. So are there some parts in the book that are not in our syllabus?
No, it's not so. Source transformation. Maybe that is consisting of source transformation. Don't use source transformation, but if all of you are interested in learning the source transformation, I can explain you. Actually, we removed it from the syllabus. But if all of you are interested, at the end I'll take it, because sometimes it's actually very good thing, source transformation. Sometimes if you apply it, it becomes easy to simplify the circuit. Source transformation. Okay. So if all of you are interested, I can tell. But it's not a part of your syllabus. So we can ignore. Okay. Can we go for now superposition? Next topic.
Yes, ma'am.
Okay. So superposition theorem. Superposition theorem here, like the question they ask like this: applying superposition theorem, find the current flowing through 3 ohm resistance. Like this is the question. This is the 3 ohm resistance given in the circuit, and you don't have any choice. Directly they mention in exam that using superposition theorem Find the current flowing through 3 ohm resistance. Okay. Now what superposition theorem state? Like Ohm's law, all of you know. While applying Ohm's law, we assume temperature constant. Okay. Means that is called as linear analysis. Ohm's law we apply to linear circuits only. Similarly, superposition theorem also, you can apply it to linear circuit only. Or in another language, whenever I apply superposition theorem to find out unknown parameters, means we are doing linear analysis. Okay, not non-linear. You can't apply superposition theorem to non-linear circuits. You like transistor, if they're in the circuit, diode is there in the circuit, then that is called as non-linear circuits. Or whatever the sources you are using, these are time variant. Whatever this voltage source or current source you have used here in the circuit, voltage source, its behavior is like, current source also its behavior like. This means it's a time invariant linear circuit it is. But if in the circuit time variant sources are there, then that comes under non-linear circuits. Non-linearity is not included in your syllabus in first unit. Okay, so what is the conclusion? Whatever I have told to you up till now, Ohm's law you can apply only to linear circuits. Superposition theorem also you can apply to linear circuit. Now the question is, what do you mean by linear circuit? See, first thing is resistance is there in the circuit. Okay, so if you observe, suppose through this 2 ohm, suppose through this 3 ohm, current is passing in downward direction, you will get some voltage and current characteristics. Now what I'll do, I'll change the current direction upwards. Will VI characteristics will change of this circuit? The question is, through resistance, simple circuit you take. Suppose this is the voltage source. Okay, across it you connect one resistance. Now through this resistance R, I am changing the current direction, initially downward and then next time upward. So this circuit characteristics, that is voltage current characteristics, will it change if you change the current direction through circuit?
No, ma'am. Only
It don't
values will be
change.
positive and negative.
Right. Characteristics will not change. That is called as linear circuit. But you take diode. Diode in forward bias mode and diode in reversed bias mode. I think everyone have studied it, characteristics. Yes, right? VI characteristics.
Yes.
See, diode in forward bias mode, you get characteristics like this. Forward bias mode means whatever is the current direction, now you reverse in reverse bias mode, right? Reverse bias mode means what? Current direction now will change through diode. Okay, so characteristics in forward bias mode of diode and characteristics in reverse bias mode of diode, are they same or different?
Different.
Different. Means if you are changing current direction, characteristics of circuit changing, non-linear circuit. Or you can say with the change, another definition of non-linear circuit, which one you will call it as a non-linear? Actually this parameter comes under unilateral and bilateral circuit. Another example is the same whatever I told you, that with the what we assume resistance is constant, but that is not the case. With the change in temperature, resistance changes. So if I am considering resistance is constant, linear circuit. But if I am considering resistance is not constant with the change in temperature, non-linear circuit. Means what is the definition of linear and non-linear circuit? If the circuit parameters remains constant with the change in temperature or time or voltage and current, then that comes under linear. But if circuit parameters, what are the circuit parameter? Resistance, inductor and capacitor. So if the circuit parameter, its value changes with the change in time or with the change in temperature or with the change in voltage and current, then that comes under non-linear type. Okay, clear to all of you? Okay, so what is the conclusion? Ohm's law and superposition theorem you can apply only to linear circuits and not to non-linear circuit. Which one is linear, which one is non-linear? Linear means what? Resistance, inductor, capacitor. I'm going to assume constant. Linear circuit. Resistance, inductor, capacitor, its value changing with the change in temperature, time, or voltage or current. Non-linear circuit. Clear? Okay, so no confusion. Only if difficult for some student to keep all these things in mind, only you keep in your mind Ohm's law, superposition theorem. You can apply to linear circuit and not to non-linear. Okay.
मैम बट कैपेसिटर और इंडक्टर के टेम्परेचर के साथ चेंज होता ही है ना, मतलब
yes change होता है. Yes, but it is not included in your syllabus in first unit. In first unit, whatever the circuits given to you, only resistances are there, not the inductor and capacitor. Means in first unit you are doing
रेजिस्टेंस का भी चेंज होता है.
हाँ yes resistance
टेम्परेचर के साथ.
हाँ
रेजिस्टेंस भी चेंज होता है ना टेम्परेचर के साथ.
yes change होता है, but whatever the methods we are using in first unit, you are doing, see, you are applying Ohm's law, you are applying Kirchoffs voltage law, you are applying superposition theorem. While applying all this, we are assuming resistance constant. Means what? You are doing only linear analysis, not non-linear. But further, if you study in third year, final year, or maybe for post graduation, that time you will use such tools or such methods in which they will consider the effect of temperature also. Then that time you will be doing non-linear analysis. Okay, as you are in first year, so only linear system analysis only included in this subject, basic electrical engineering. Clear? Got it? But in further years or maybe for post graduation also, non-linear system analysis also you can do. Got it? If you go for non-linear system analysis, then results will be more accurate compared to linear. Clear, everyone? Okay, can we go for next? Okay, so superposition theorem, it is applied to linear system only. You cannot apply it to non-linear. Superposition theorem you are applying means you are doing linear analysis, not the non-linear. That is the another sentence I can say about superposition. Now what you have to do here, using superposition theorem, find out the current flowing through 3 ohm resistance. Okay, now see here what superposition theorem state. See, minimum 2 sources must be there. If only single source is there, you can't apply superposition theorem. Whenever you wanted to apply superposition theorem, circuit must be linear. Again, in the circuit, minimum 2 sources must be there. If only single source is there, you can't apply superposition theorem. In the circuit given to all of you here, whatever all of you can see circuit, see, this one is which source? Current source. Correct. DC current source. It's a symbol for it. Okay. 5 ampere DC current source. Arrow direction is upward, means like this 5 ampere current will flow in this direction. 5 ampere in upward direction. Okay. That is its meaning. One source is 5 ampere DC current source. What is the another source? Yes.
Voltage source.
20 volt DC voltage source. 2 sources are there. Both can be current, both can be voltage, one current, one voltage. Okay. Minimum 2 sources must be there. Then only you can apply superposition theorem. 2 or more than 2 sources, you can apply superposition theorem. Okay. So here 2 sources are there. One is voltage source 20 volt. Another is current source 5 ampere. Okay, so you can apply here superposition theorem. Okay, next thing is what this superposition theorem states: consider single source at a time. means I'll consider first 5 ampere only. Okay. I'll consider first 5 ampere only. Attendance link I'll post up. Just 2 minutes. So see what this superposition theorem states. Now here current, suppose you get asked find out current flowing through 3 ohm resistance. Okay, using superposition theorem. So what the superposition theorem states, you have to consider single source at a time. Okay, consider single source at a time. Hence I'll consider initially only 5 ampere. What you have to do with then the rest sources? Rest sources you make inoperative. Inoperative means what? If voltage sources are there, make them short. Okay, voltage sources are there, make them short, and if current sources are there, make them open. Got it? What this theorem states, whenever you apply superposition theorem, consider single source at a time. I'll consider only 5 ampere. Then what do you have to do with the remaining sources? If voltage source is there, what you have to do it? You have to make it
Short.
short, correct.
Short.
And if the remaining sources are short circuit, I make this clear concept in previous lectures also. Short circuit, open circuit. We'll explain. You please refer my previous material. Short circuit means what, open circuit means what. We'll explain again. Your voltage sources you have to make short, and current sources you have to make open. Short means what? Across this 20 volt you take one wire, connect across it, or you remove it from the circuit like this and close it with some wire. We'll explain what exactly mean by and current sources you have to make open circuit. Open circuit means what? Remove it from the circuit. Okay, current source ko remove karo. Or at this point you got, okay, consider single source at a time, and what you have to do with the rest sources? If voltage sources are there, make them short. If current sources are there, make them open. Clear? Voltage source को क्या करना है?
Short.
Short. Current
Short.
source? Current source?
Open.
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 Okay. Short means what? See, suppose I am assuming here only 5 ampere. Now another one is voltage source, so you have to make it short. Short means what? प्रैक्टिकली क्या करना पड़ेगा आपको? 20 वोल्ट जो वोल्टेज सोर्स को दो वायर्स है, ये एक पॉजिटिव को कनेक्ट किया है, एक निगेटिव को कनेक्ट किया है, वो वोल्टेज सोर्स के दो टर्मिनल को हटा दो और वो दो वायर जो थी कनेक्ट देम टुगेदर, मींस इट विल एक्ट लाइक अ शॉर्ट. मींस 20 वोल्ट सर्किट से निकाल देना है और 20 वोल्ट के पॉजिटिव एंड निगेटिव टर्मिनल को जो दो वायर कनेक्ट थी, connect them together. Is this clear? Okay, see, one wire is connected to positive terminal of 20 volt, another wire is connected to negative of 20 volt. 20 volt voltage battery you remove from the circuit. Now whatever these two wires, their two ends join together, that is called as short circuit. And if it is a short circuit branch, then its resistance is what?
Zero.
Zero. Very good. Means maximum current will flow through this branch and no current will flow through 4 ohm. Means whenever this 5 ampere reaches at this node, some current will flow through this. Suppose I am marking this as I1 dash. This I1 dash current will flow through 4 ohm or short circuit branch? Short circuit branch, right? Then this I1 dash will come like this, and this whatever current coming and this I1 dash again 5 ampere will return back to source. Clear? Like this. Okay. So what this theorem state? Rest source, you consider single source at a time. So we have considered 5 ampere. and make rest sources inoperative. So only one source is there, that is 20 volt. We have shorted it. Now with this, you have been asked to find out the current flowing through what? Yes.
3 ohm.
3 ohm. So with
ohm.
only 5 ampere, find out the current flowing through 3 ohm. Okay, any method later on you can use. So find out. Now you tell me current flowing through 3 ohm. Suppose I am going to mark it as I1 dash. So what will be its direction? Upward or downward? When single source is there, you can confirm tell the
Down.
current direction. If two sources are there or more, if more than one sources are there, then it becomes difficult to exactly tell the correct current direction. But if only single source is there in the circuit, you can easily find out or can tell correct current direction flowing through 3 ohm. So suppose through 3,
Downward.
correct, downward, because when 5 ampere comes like this, some current will flow in this downward direction. Through 2 ohm some current will flow, that I am going to mark as I1 dash. So current flowing through 3 ohm is I1 dash and its direction will be downward. So if current flowing through 3 ohm is I1 dash, how much current will flow through this 10 ohm?
5 minus I1 dash.
Correct, 5 minus I1 dash. Clear? Okay, so like this everyone can find out the I1 dash. And its direction is downward. Now what superposition theorem state? Consider another source. So which one is another source? 20 volt. This I will consider and make rest sources inoperative. Now which one is rest source? 5 ampere. That you have to make inoperative. So you will make it short or open?
Open.
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 So across, suppose this two terminals I will mark A and B. Make open. You have to make it open means what? From circuit remove 5 ampere current source and keep these two terminals open. Okay, so here open circuit will be there. Open circuit means what? Resistance is
Maximum.
infinity. Means
Infinite.
no current will flow from A to B. Okay, means suppose I will mark this current as I and current flowing through 3 ohm. Now in which direction current will flow through 3 ohm? Upward or downward? Upward. Correct. Okay, I told you if single source is there, you can correctly trace the current direction through any resistance. So that I will mark. Previous one was I1 dash. So this one I will select I1 double dash. Okay, got it? I1 double dash. Okay, so I1 double dash we have selected. It will flow in upward direction. Now you can easily find it out. I1 double dash, find it out. So we have find out I1 dash and I1 double dash, and its direction also you can easily specify. Now we wanted to find out what is the question you have been asked. You have been asked find the current flowing through 3 ohm in the given circuit. In the given circuit means what? When 5 ampere is also there and 20 volt is also there. So what this superposition theorem states, now when both the sources are there, exact current direction through 3 ohm, whether it will be clockwise or upward or downward, it's difficult to predict. But any current direction you assume when both the sources are there, I will assume it as upward and I will consider it as I1. Okay, I will consider it as I1. Okay, so any you can assume here downwards also. Is this clear to everyone? This point is important. When both the sources are there, I will mark this variable as I1, and current direction you can show upward also, downward also, doesn't matter. Okay, I have represented it upward. You can assume downward also, doesn't matter. Now see what this superposition theorem states. See this equation. I1 is what? Current flowing when how many sources are there? Yes, I1 is the current flowing when how many sources are? Both the sources are there, correct. And which one current direction I have assumed? Upward. You can assume downward also. What is I1 dash? Is the current flowing through 3 ohm, that is the load resistance. current you have been asked to find out through 3 ohm. So you can mark that as load resistance RL. Whenever you get asked find the current flowing through 3 ohm, means 3 ohm is a load resistance. Clear? RL. And current flowing through 8, you can represent IL also. Here I can write IL, IL dash, IL double dash. Clear? Load resistance. Okay. Whenever in exam you get asked, or whenever in the numerical you get asked, find out the current flowing through 3 ohm. So that 3 ohm resistance you can call as a load resistance RL. Current flowing through 8 rather than I1, you can represent IL, IL dash, IL double dash. Is this clear?
Yes, ma'am.
Rather
Yes,
than I1, you can use IL, IL double dash, IL dash like this variables. Okay. So here, see, I1, we have assumed I1 is the current when both the sources are there. Its direction we have assumed upward. I told you with 5 ampere, obviously current will flow in the downward direction. Here, no need to assume, definitely there will flow in downward direction. And with 20 volt there, which one variable we have assumed? I1 double dash, and obviously there it will flow in upward direction. Now with reference to this current direction, okay, is this clear? I1 upward and I1 dash when only 5 ampere is there, that one obviously downward, and with only 20 volt I1 double dash in upward direction. Now what you have to do with reference to this direction, what this superposition theorem states, whatever the current flowing through load resistance when all the sources are there is equal to algebraic sum of current flowing through load resistance when considering single source at a time and making rest sources inoperative. Algebraic sum means what? With reference to this current direction, you mark the polarity. Now see, it is upward and this is downward, means you have to assume this as negative. This one is upward direction. With reference to this, I1 double dash, in which direction it is flowing? Upward. So with reference to this sign will be positive or negative? Positive. Algebraic sum. Algebraic sum means what? With reference to this current direction, mark the sign over here. These two are opposite. That's why here it will be negative. These two are in the same direction. That's why here it will be positive sign. Is this clear? What superposition theorem states clear to all of you? Yes. What it states?
Yes,
current flowing through load resistance when all the sources are there in the circuit according to superposition theorem is equal to algebraic sum of all currents flowing through load resistance considering single source at a time and making rest sources inoperative. Making rest sources inoperative means what? If voltage source are there, make them short. If current sources are there, make them open. Clear? Superposition theorem clear? Okay. So
Yes,
what
ma'am.
is it? Superposition theorem. You can apply it to linear circuits, same as that of Ohm's law. Ohm's law superposition theorem you can apply only to linear circuits and not to non-linear. Okay. To apply superposition theorem, minimum 2 sources must be there. 2 or more than 2 sources, go for superposition theorem. You can go for superposition theorem. But if in the circuit only single source is there, you can't apply superposition theorem. Okay. Then according to this theorem, what it states? Consider single source at a time. Make rest sources inoperative. So what you do? Consider only 5 ampere C. Make 20 volt short. With 20 volt shorted, find out I1 dash. Its direction, you know. See here calculations I have done. Then consider second source 20 volt. Make current source open. With this, find out I1 double dash. Its direction will be upward. Any method later on you can use. See I1 double dash 1 ampere in upward direction. I1 dash 3.75 in downward direction, right? So then do algebraic sum. I1 you can assume upward also, downward also, doesn't matter. I have assumed upward with reference to this. Opposite direction minus, same direction plus. So do it. You are getting answer minus 2.75. Answer is minus 2.75. What does it mean? Yes.
Opposite direction.
Means whatever you have assumed 2.75 current in upward direction, that is wrong or reverse. It will flow in
Downward direction.
downward direction. Clear superposition theorem to all of you?
Yes.
Yes.
Okay. So okay, clear everyone? Hello.
Yes, ma'am.
मेरे को इनकी कैलकुलेशन दिखा सकते हो?
Next time
3.7.
next time we are going to simplify this sum. You take notebook, pen with you, draw the circuit one by one. Each step I will explain to you, and all of you please simplify it. But exactly to explain theory, this directly numerical I considered. Is this clear to all?